Yes,
Perfect.
good. All right. Well, thank you for attending this afternoon. I know it's for several of us, it's almost a week for holiday, but I'm glad to have you here. My name is Jochen Teizer. I'm a professor at the Tekniske University of Denmark, and I'm showing today work of our team contributing to the BIM2TWIN project. Primarily also work from the doctoral students Carsten Johansen and Keping Hong. Yeah. Bruno, you mentioned it already. I think we tie here as a major, or as one of the components into the BIM2TWIN project, where we talk about safety, and I think it's a central element, as we all know, in construction projects. And I think what's important for us is to actually advance construction safety to the next higher level. And I think in this concept of the digital twin platform that we have in BIM2TWIN, we of course expect data to be provided to us that we can further process and then enrich the decision making of safety professionals. That's it in a nutshell. There's a lot of technical details that I can go into. I'll try to stay on a high level, but if there's details or questions, I'm more than happy to answer those ones. Important to note is, a dashboard in the end that's useful for the end user, let's say on the construction site, is our kind of goal. And I'll show you a little bit of that, what we can provide. Just a little glimpse of what we have contributed. Just a very basic introduction to safety. If you're not familiar with it, safety is always priority number one. And yet it often doesn't have that focus. And yet there's many different concepts available, like the safety pyramid you see here, which tells us we should focus on close calls rather than just fatalities, because fatalities are so hard to assess and control. And yet even the latest and greatest work, I would say, in the construction safety research and development area tells us that we need to even shift further than just looking at close calls and so-called leading indicators. Actually, it's going into high energy control events and actually also prediction. Prediction is very suitable for digital twins, as we know, as we can process data. And that will hopefully help us bring this curve further down to zero. As we know, the safety has been leveling out for the past couple of, almost 2 decades now. We need to take the next leap and improve things. And that's where a digital twin really comes in handy. To tell you a little bit more about the digital twin that we have built, I know this graph is very busy, but you have here a construction site. Actually, work package 7 in BIM2TWIN produces alternative construction plans according to the lean construction method. We can evaluate those alternative construction plans, let's call it schedules, and evaluate them for safety. So this is where we focus on a artificial intelligence to evaluate safe construction plans for safety. We call this tackling the prevention through design and planning principle. In addition, we also want to, of course, focus on understanding what is going on a construction site. That's where we have raw data streaming in. Here we focus on sensors, whether they are vision-based or wireless sensors or variables that provide us with data about the workforce and equipment that's moving around. Even that data can be analyzed and used for predicting probably future events. So you will see a little bit on that. Of course, we want to relate this information back once we check with according to rules to the end user, which is then shared again with the construction site. I think we have numerous publications among the entire BIM2TWIN team. I would encourage you to read up on that and maybe even contact us. But I'm not going into further detail. That there is underlined business processes that we have evaluated in the BIM2TWIN project to really figure out what data do we need, what information can we generate, and how can this eventually be used as future knowledge. So I'll show you two parts. One is the safety planning that has, and the other part is proactive monitoring and control. I stick just to those two. The objective of safety planning is to design out known hazards from construction scenarios, from construction plans. So often these relate to rules. I'll show an example in a second. And second, we want to come up with a semi-automated way to identify these hazards and actually eliminate them before we go into the construction phase. So, and the output is then, of course, we want to almost automatically suggest mitigation or measures, equipment, safety equipment that protects the workforce from getting hurt. I think if you understand that these parts here, then I think I can show you the next couple slides. This is how it's done currently, planning safety manually, like on a drawing. And yet we want to go to that phase where we actually utilize building information modeling, like figuring out where fall from height hazards and actually creating fall protection equipment automatically in a BIM model and linking that to the schedule. Now, to show you this, I hope you can see it, and the video is quite smooth. Typically, you have this in a construction plan, a model, but it doesn't carry any safety features. So here we actually, once we run our algorithms, we can actually detect these fall hazards and install automatically these guardrails. And I think that's a first result or contribution that we have been making with our work package in BIM2TWIN, that we can detect these fall hazards and either put guardrails there or other protective measures as the user wants to have. I move here to the next slide. We have, of course, multiple demonstrator sites in the BIM2TWIN project. One is in Spain, one is in Finland, and we have applied these tools there to generate these safety plans or safe building information models. So it's a very nice way to actually incorporate safety and leverage the already ongoing effort of utilizing BIM for construction projects. Then the question is, what do people actually get out of it? I mean, thinking about when you log into the digital building twin platform, I mean, simply speaking, from an end user's perspective, this is what you get out. This is for a little demo project here, but I think it shows very nicely the contribution it is making. We have a construction schedule that's increasing, and you can see as the building is being built. Maybe you just watch where my cursor is. Okay, hopefully you can see. Can you see it? Yeah, I think you can see it now, right? You can see the building is moving upwards, being erected. We also have hazards coming up or actually disappearing as we move up. For example, the facade element is being attached to this high-rise building. And then actually we can also determine the quantity of the safety equipment that we have. For example, the length of guardrail. That's probably very interesting to figure out what is the investment / cost of safety equipment on a construction project. And likewise, we can determine the exposure of the work crews. And I think that's very interesting because here we tie to our work package 7, which comes up with lean construction plans, maybe location-based schedules of work crews in a building, and we actually can determine, is a work crew actually exposed at that given time when they have to perform a task in an area? Are they exposed to that hazard that we have actually detected in the schedule? And you can see that here as well, right? The exposure of the work crew as the project evolves. I think this is some basic takeaways from what we've been doing in BIM2TWIN on the safety planning phase. We call our approach Safe Con AI. And actually, as it ties to work package 7, typically we have a construction schedule as shown here. And we know that this is probably not as efficient as it could be. The one below is probably a bit optimistic, but technically, based on work package 7 and our contribution, we can incorporate, first of all, safety. So it's very small to see here, but we include actually safety. So we know when safety issues occur and and how quickly they have to be fixed. And likewise, we can, of course, streamline the operation and make it lean, reducing further waste. So that's something that is a result of the safety planning part of our work package. Going to the next part, of course, having this plan here, it would be nice to actually monitor, are we actually performing that well as we have initially thought? And here we have the objective in this part of the project of monitoring real-time safety as it is practiced on the construction site. So here we track actually workers and equipment locations and detect safety relevant incidents. and the output is then a quantitative analysis of what has happened on the construction site. Let me show you a little bit of that. Here you see a model. Actually, this is also a result of our safety planning phase. We actually take a model and enrich it with the walk spaces. So you see here in the light blue color, the walk area of walkers. Actually, here is fall hazards because the walk crew is walking on that end. You see here there is no prefabricated wall element, hasn't been installed yet. So you actually can drop here at least 2 meters, as we have experienced it in a field trial on the site. And so walkers could be exposed in that part of the job site to these falls. Now, how can we actually ensure that walkers don't drop, or how can we record that they don't got too close? Well, we can put wearable tags on them, which we have done using RTK GNSS tags. These are tags that can track to a level of the centimeter accuracy where walkers are, of course, only in the outdoor environment. And it's working like you set up a base station that provides the corrective signal, and actually, or you use an online service, that's also possible. But in this case, we developed our own base station and installed it. Likewise, we also installed a camera on the train, the crane hook, on the trolley as it looked downwards, to also figure out, can we detect using computer vision any walkers below a heavy load? Because of course, we also would like to avoid that. Yeah, and you will later see more from Markus, more about computer vision. I'm not going into that too much, but this is raw video footage or images from the video footage. And then there is algorithms initially provided by a partner in the BIM2TWIN project that can actually process the raw footage and detect walkers just below a crane load. An incident yet you see here is probably that this walker might be exposed to this load hanging to the crane hook, and we want to avoid that, so they stay away. And so that's exactly what we can do. And once we have georeferenced these images, we can actually map all the trajectories. So this is from the RTK GNSS data, all trajectories. So you see this is from just 5 walkers, all the trajectories throughout one day. And you see their work area. So you can quite easily figure out visually that they have been working quite a bit in this domain. And likewise, the crane hook can be visualized because we also have its position, since we also installed an RTK GNSS tag on the crane trolley. And we can bring that into relation to the walk crew. So any one of those red circles actually indicates that there is walkers being too close, or maybe even underneath the crane hook. And that could be an indication telling, hey, we should probably do something here, and actually probably show an image like that in a toolbox meeting the next day, or maybe in the same day in the afternoon, telling them, hey, look, guys, step away, or let's find a different way to actually erect these prefabricated concrete elements. So this is a very simple way to do that. Of course, here's another way to display it. You see it here in the, again, on a plan view of the safety enriched BIM model. You see it here, these locations, whereas the yellow ones, maybe not as serious. And of course, you actually are able to get a lot of data about the workers, like who of the workers was exposed at what time, and so on. Now, we're still in the process of analyzing how this such data can be, or such information can be shared with the workers in a better way. But our goal here is to use active personalized feedback, where we directly approach the individuals and tell them how important it is for their own life to ensure safe work practices. I think, this is it from my part. Of course, we have a lot more statistics about a job site and its behavior, but I think you get a glimpse of what is nowadays possible once you use technologies, Internet of Things, or sensors that provide data from the real construction site operations. Yes, I don't know how we would like to proceed. Maybe do the next and then have questions, or yes, I think that's the way to do it. Good, then I'll probably stop sharing.
Then I will take it over. So I started sharing my screen. So hopefully it's visible. The slides are visible. Yeah. Okay. Very good. Yeah. Also a warm welcome from my side. So my name is Markus König from the Ruhr-Universität Bochum in Germany, and I want to present our contributions within the BIM2TWIN project regarding the monitoring of construction equipment. This is, of course, also mainly the work of my PhD student, Dennis Pawlowski, and I will show you also some more results, not in that detail about every algorithm, but I will show you how we can integrate some information about the equipment also in the digital twin platform. So actually, Jochen motivated, of course, a lot regarding safety because it's a very important topic. However, also safety is somehow connected with the usage of equipment on the construction side, big machines, and of course, there's always a collaboration between the machines and the workers. Of course, also there we can detect some hazard. So also we did this in the BIM2TWIN project, but maybe we had not the time today to show everything. Another important topic, of course, is the usage of this equipment. So in a way that we make our whole progress, our own construction a little more efficient. So actually it's about to know where exactly is a certain machine, what is the machine doing, and of course not only a machine, maybe also about other resources like formworks or precast elements. So we want to monitor them and maybe to track these objects and try to analyze some kind of extract some information, how efficient was this usage, how we can maybe optimize this later regarding our updated schedule. So mainly I'm talking about tracking and monitoring of construction equipment at the moment. So also here are several technologies possible. Here, of course, sometimes you have machines with already installed sensors, so you can collect data directly, but also very often we have equipment which is not that intelligent or not that digital, so you have to monitor it in a different way. Also here we are using computer vision based methods, so installing a camera somewhere on the construction site, then of course starting the recording, try to identify where is equipment or a machine, what is the way the machine is moving along the construction site, what is the machine doing, and then transfer all the information into our digital twin platform and try to analyze them. And as Jochen mentioned, so of course, everything is about to make the whole operation more efficient and more safety. And of course, in general, we want to update our schedule. This was also a part of the BIM2TWIN project, but it's not the topic of today. So I want to go into more details and show you some of the results. So actually, the main idea is to find out where is the machine located. So really to calculate the coordinates of a machine or maybe all of a worker or other equipment. Then, of course, we can also find out if you have maybe a video. So we have different images to which we can analyze, that we can calculate trajectories from an object. So where is the direction the machine is moving? And of course, very important is also that we have to check if the machine is in a so-called working zone or different zones on the construction site, that we can say, okay, there is some construction work is going on, the machine is unloading or loading something, and maybe then move to another part of the construction site. So we are concentrating here in the BIM2TWIN project on different equipment types like excavators, concrete mixers, trucks, rollers, excavators, also tower cranes and mobile cranes and so on. So that's always a little bit the challenge if you use computer vision and you want to detect a certain machine. You have to train your model for this certain type. So if there's a type not trained in our machine learning model, then we cannot detect it. So this is always a challenge. Therefore, we collected a lot of images from different countries, from different manufacturers, to make a very robust estimation to identify the machine and also to detect the movement. Of course, if we have this, then of course we receive an image in general, check if a certain equipment appears in the image. Of course, we are also looking up a list of possible equipments which are maybe scheduled or planned for the construction works. So of course, if you detect a certain type of truck and it was not really planned that you are using this truck on the construction site, then of course you get the information. Maybe there's some wrong configuration or a modification on the usage of equipment. So there's always a so-called list behind, so that we have a list of equipment. And then we also look up if this equipment is supposed to used on the construction site. Then of course we can also track these different objects here in different images of different parts of the construction site, and then we provide mainly the coordinates and the type to the digital twin platform, and then we evaluate these results. So this is what we are developed. So some kind of algorithm. So we put the camera on the construction site, also on our pilot sites in Finland and Spain, and you can see it's classifying a dump truck, and you can also calculate the speed of the truck and also what is the distance between the camera and the truck. So it can be also shown on the right side. This is a movement, and you see this is the camera view. We can do this also, you see in the background a little bit an excavator moving, so this is also possible. So this we can achieve mainly in real time. Of course, here's another video. So of course, then you can identify if, of course, an equipment is moved to a certain position and stopping there, and so there is also planned to do a construction work. Then you can estimate, okay, now maybe there's an unloading of this concrete mixer here. So from the detection of the equipment, you can also have some forecast what maybe is the main activity. However, of course, you can also try to analyze this if really some material is coming out of the machine. However, a good estimation is always if it's at a certain position and it was planned that there's a construction work for this day, then you can estimate, okay, they are really doing the work at the moment. Of course, we can also show the trajectories of machines, of workers, also as Jochen showed us in his slides. So here you see, of course, also we try to find out where are maybe the construction area. So there we worked around and tried to detect also some elements of the trench and the fence, for example, and then we have maybe a trajectory. Okay, here's the location of the construction area and the construction site, and then we have maybe, I only show some of the lines here, that we have a dump truck coming in and an excavator, or a certain machine is moving into a certain zone for pouring or cleaning some objects here. So of course you can always analyze all the information. So we are collecting this data every second or more often, so that it's real a lot of detail you can take out of this data for analyze this. However, we are facing, of course, several challenges when we are setting up a machine learning model to detect some of these objects in the images. Of course, we have to check if this is working on for different weather conditions. For example, so we have snow here on the construction site on the left side, or we have maybe not a good image, maybe the quality is quite bad. Then you see the accuracy of the detection is going down a little bit. So for the excavator here, we have only a 68% reliability that we really, this is really an excavator. However, maybe it's enough. For other things you see for this dump truck here, it's sometimes quite accurate, but so also for not so good images regarding the quality. However, a lot of problems occur if you have a lot of machines on one image. However, you have a multi classifier here, so it's also working very well. However, if you have a machine and you use a very simple classification algorithm, for example, for the pump truck here, or the so that's a pump, concrete pump here. You see the dimension is very large, so it detects in the whole image there's somewhere this concrete pump. Of course, sometimes it's better also to separate this in several parts, that you have only maybe the machine or the truck or the vehicle itself, and maybe then the other parts of the pump. Of course, it's also possible. However, you have to train it in a different way. So it's really important to think about how you can, what you want to achieve, and which is available, which data you need, which classification, if it's enough to identify only there is an object, or you need further details, then maybe you have to enrich maybe your training set and use maybe also other machine learning methods. However, you can also apply this for other resources and material. Here we also can detect, for example, formwork elements, so single elements and also assembled elements. And of course, we also did this for selected precast concrete elements on the construction site. And of course, it's also possible, of course, to apply this to workers, as also Jochen showed us. So it's also possible, of course, not only from top view. You have to train it then from a side view, maybe also that you get a good overview what is going on your construction site. Here you see maybe the tracking of the single formwork elements. You see it sometimes it's not so accurate, but actually it's maybe we only need the information. There are several elements. Maybe there's an assembled big element, a group of elements, but we can also detect which individual formwork elements are now connected to a bigger one. So this is also possible. However, of course, for formwork elements, it's highly dependent sometimes on the color of the elements. You have different manufacturers with different colors. You only have to train it for different colors that it's really working. Now I'm coming to our digital building twin platform here. So as Jochen already mentioned, so regarding quality control and safety and production planning, we also want to upload, of course, our information, our data to the platform, and want to visualize this also in the dashboard. Of course, this is also possible. You can just analyze this like you're doing this with Excel. So where are the positions on the site? What are the quantities? What is the utilization rate? And so on. So you can really analyze all the data and find out if you have maybe some points where you can optimize the next construction works for the next work for the next months, or you can highlight some machines which are maybe not longer so it's not necessary to use them anymore, because maybe the construction itself it's a little bit slower. So it depends on your questions and what you can get out of this, but we provide all the information, all the data via the platform, and have different possibilities to aggregate the information in such charts here. However, it's also possible to connect the digital twin platform to other tools. So we also developed a so-called web-based interface, so that we have an existing BIM application, for example, to just connect to the digital twin platform, download the information and visualize them maybe in a BIM viewer or in another tool. I will show you this maybe in one tool which we are very often using in Germany. It's called DecideMD. So it's quite easy to connect to the digital twin platform. Just download the IFC files, download all the information. Here you see different areas and also the position of the machine. You can also visualize this, of course, simple lines. And of course, you can also do some querying using this more complex BIM applications. So what are lessons learned and next steps? Of course, vision-based methods can be really easily used if you have the training data. So it's very important, of course, that you have good images, for example, for training your models. Then you can really monitor construction equipment, because it's quite easy, because this is an object with a fixed dimension. So for machines, it's quite easy. However, for other resources, it's a little bit more challenging, like for formworks, maybe scaffolding here. So then, of course, because it's assembled of separate tiles or single elements, then, of course, it's getting more and more complicated to detect these elements and to analyze them. However, it's also possible, but we still need to train our models a little bit better here. And of course, if you have a new machine, new resource, new material on the construction site, you have to train it again and again. However, sometimes it's possible to transfer some experiences from other training processes to new training processes of the machine learning models to make it a little bit faster. However, we are still working on that. So, and thank you for your attention also from my side.
Thank you very much. We now have a couple of minutes for questions and answers. So please feel free either to ask them directly, to write them in the chat, or to write them to me, and I will read them loud. Okay, we have a question about equipment, which is, how can it be recognized whether a machine is working or simply waiting at a location?
Then it's for me, as I mentioned, yeah, it's of course we are just tracking the machine, and sometimes, of course, it's not really quite clear what the machine is doing. Is it really just stopping, or you do some operation? So very often we assumed the activity of the machine. However, of course, it's also possible to train if maybe the crane maybe moves around and has a material or resources on the it's on the crane and move around. Then of course the crane is operating, so you can also detect this. Also, Jochen showed us this. However, for some machines, it's not it's so easy. Then maybe it's also possible to collect other data or analyze other information. Maybe there's a worker standing by doing something. So the combination between worker and machine, maybe it's also an assumption that maybe there's an operation going on. However, it's not always that easy, but of course, it's also sometimes possible to do this with computer vision based methods.
Thank you. And okay, there is another one, which it's still for you, Markus. How can other sensor data, for example, data collected directly by construction equipment, also be integrated into the concept?
Yeah. So also we had here a smaller task where we tested out that we maybe directly collect some data from a machine, because of course newer machines of course collect exactly when they are operating. They have of course a very good GPS position. So it's possible. So the digital twin platform is capable for storing this information also, and we can also analyze this in the same way. However, in this project, we mainly focused on machines which are not that intelligent at the moment. So therefore, we thought, okay, it's good to maybe add additional sensors like cameras on the construction site to collect this data. However, the platform itself, it's prepared to store this data, and it's also connected to other information in the platform.
I can add to that point, Markus, you said it correctly. The digital building twin platform is capable of handling such data, and yet it's really challenging to access machine data because the owners of the machines may not want that, or the equipment manufacturers actually don't share the access. For example, the protocols, Canvas, etc. Everybody who's familiar with it knows that these are very difficult to actually connect to. In our part of the work, we were interested in safety. We tried to solve this problem too, and yet we would have been forced to cut some wires in the machine control system. And of course, the current owner of a machine would not like to do that, because they would void any warranties that they have on the machine. So technically, it is possible, even if the equipment manufacturer doesn't give you the direct access to the canvas. But there's lots of hurdles that actually should be regulated, in my opinion, to actually also give open access to machine data. So I see an open data sharing formats. That's all fine, but we need the same for machines to really go to the next round of innovation. And I think this is also one finding from the BIM2TWIN project, at least from our side.
Yeah.
Thank you. I think there are no further questions. I didn't receive any. So I would say we are perfectly in time. We can close the webinar here. Thank you very much to all of you who presented and participated. As I mentioned at the beginning, you'll find the recordings of all webinars in our webpage that I copy and pasted in the chat box. And for those who will be present, we'll see you on the 1st of April. Thank you very much and have a good day.
Thank you.
Bye.
Bye-bye.